welcome to Chem Camp. I'm Mrs. Newman. AP Chem students, do you realize that the College Board is going to expect you to know exactly what a hydrogen bond is? And that they love to ask this type of question on their multiple choice section of their exam? So this would be a real easy problem to pick yourself up an extra point in May. Every point counts, you know. So let's learn a little chemistry. It reads, in the diagram above, which of the labeled arrows identifies hydrogen bonding in water? Now, this little diagram, believe it or not, has a plethora of information, and we're going to break it all down. But let's start with remembering exactly what a hydrogen bond is. First and foremost, you have to keep in mind that a hydrogen bond is actually an intermolecular force. Now, intermolecular forces are forces or attractions between different molecules. It's actually a very special type of intermolecular force, though, because it has very specific requirements. So listen carefully. A hydrogen bond will only form with molecules that have a hydrogen atom bonded directly to a fluorine, oxygen, or nitrogen atom, F, O, or N, or phone, if you will, within the molecule. Only then can a hydrogen bond form between the H end of one molecule and the F, O, or N end of a different molecule. This actually winds up being the strongest type of dipole-dipole interaction you can have. Now, water is a perfect example of a species that undergoes hydrogen bonding. Let's talk about water for a minute and understand exactly why. First and foremost, water, or H2O, has two hydrogen atoms covalently bonded to an oxygen atom. Now, covalent bonds form when atoms take their atomic orbitals and form what's called an orbital overlap, so that their electrons can share that common space, which is why oftentimes people refer to a covalent bond as one where electrons are shared. But if you've learned about covalent bonds, then you know that atoms don't always share electrons equally. And that's the case here between the hydrogen and oxygen atoms within the water molecule. The reason being, oxygen is much more electronegative than hydrogen, meaning it has the ability to pull those electrons in that bond closer to it and away from those hydrogen atoms. This causes the development of partial charges. For instance, every oxygen end of a water molecule is partially negative, where we use the lowercase delta symbol to mean partially. And since those hydrogen atoms are having those electrons move away from them, they each become partially positive. This makes water a polar molecule. And since within that molecule the hydrogen atoms are bonded directly to those oxygen atoms, it allows water to form these hydrogen bonds. Now, there's one other piece of information we need to keep in mind. Like we said, or have established, the bonds between the H and the O within the water molecule, those are your covalent bonds. Those are called intramolecular forces because they're within the molecule. When you're dealing with covalent molecules, the intras, the covalent bonds, they will always be represented by a solid line. because the intras for covalent molecules are always stronger than the inters. So when you see a covalent molecule's inter drawn, in this case the hydrogen bond, it's going to be represented by a dotted line because it's going to be a weaker bond. So let's analyze each option the College Board gives us here. So in this first molecule, or letter A, if you take a look, that arrow is actually pointing towards a solid line between the O and the H, and that's within the molecule. So that means that that's an intra force, meaning that letter A is not an option here. Let's take a look at letter B. Letter B is much better. It is, in fact, pointing to a dotted line, which again is going to represent that intermolecular force because it's weaker than the intra. However, look carefully. That line is drawn between two oxygen atoms on opposite molecules. Each one of those oxygen atoms is going to have a partially negative charge. Now, this is just crazy talk. What you need to keep in mind is that in chemistry, opposites attract. So in order to have an intermolecular force or a hydrogen bond here, you need to have opposite partial charges. Two partially negative charges are not going to work. So letter B is also not an option. Letter C, it is pointing to a dotted line, but again, be very careful about what you're looking at. You've got two hydrogen atoms from two different molecules. Well, each one of those hydrogen atoms are now partially positive. And again, this is just plain crazy talk. The same charge or like charges, they're actually going to repel each other. They're not going to attract each other here. So letter C is also not an option. Let's take a look at letter D. Letter D is showing that dotted line between a partially negative oxygen atom and a partially positive hydrogen atom of two separate molecules. And that hydrogen atom is bonded to an oxygen atom within the molecule. So letter D is in fact our hydrogen bond and the answer to this question. I hope this helps you prepare for your AP Chem exam in May. Continue to follow along for more AP Chem content. See you soon.